pardon my drawing, is a freehand sketch and is an interesting math question. So let's focus on getting the solution to this particular interesting geometry question. So today we are told that the value of this line from here to here is 16, from here to here is 9, and this is not drawn to scale, as you can see. Now the question says that we should find the area of this bigger circle. Now I want you to note, you can see that we have a secant. This line is a secant, right? And we have a tangent, and both of them meet at a point. Now, using the tangent-secant theorem, if we call this point A, this point of intersection, okay, let's call this point B. Let's call this point of intersection between the circle and the tangent C. Let's call this meeting point D, okay? Now, according to the tangent-secant theorem, it states that this length CB, that is the length of the tangent, CB squared, should be equal to DB multiplied by AB. All right? So it means that CB squared is equal to, now DB is 9 and AB is 16 plus 9. CB squared is equal to 9 multiplied by 25. Now if we take square root of both sides, if we take square root of both sides, then we will have square root of CB squared is equal to square root of 9 multiplied by 25. Okay. Recall that square root of A squared is equal to A, and square root of AB is equal to square root of A multiplied by square root of B. Now, it means that this will remove this, we have CB is equal to, this will be square root of 9 multiplied by square root of 25. So CB will be equal to 3 multiplied by 5. So CB will be equal to 15. So it means that this length from C to B is equal to 15. So let me write it somewhere. If this is the first time you are seeing us, please click the subscription button, turn on your notification bell so that you don't miss our videos, okay? We upload our videos as often as possible. Tune in at your convenience. There must be something new for you to watch by God's grace, and give us a thumbs up if you love what we are doing, okay? Thank you very much. So we have gotten CB to be equal to 15. Now, if I join this point of intersection between this circle and the tangent to this common point here, all right, you will notice that I have formed a triangle CDB. All right, triangle CDB. Now in triangle CDB, recall that if I decide, you are not recalling anything, I just want to get something from here. Now if I decide to draw a straight line from this point across to this point, okay, so this is a straight line. Sorry, it's not actually straight, but that is supposed to be a straight line, and is meant to pass between these two circles, the point of intersection. You know, this is a freehand sketch. All right, now let us call this point N. Now you can see that we have triangle CDN and triangle DNB. We are almost at the end of this lesson. Yes. Now, first things first. Remember the external tangent theorem. in circle. It says that if you have a circle and you have two tangents meeting at a point P, if this is tangent AP and this is tangent BP, that these two lengths are equal from the point of intersection or the point of meeting, they are equal. Okay, so if you look at this, you can see that CN is a tangent and DN is another tangent, and this is their meeting point. So it simply means that CN is equal to DN. So CN is equal to DN. All right. Similarly, NB is equal to ND. So NB is equal to ND. So which is also equal to NB or BN. Now, where am I driving at? If we decide to call this particular angle here alpha, it simply means that this angle is also alpha. Because when two sides, I don't know what is this. When two sides of a triangle are equal, the base angles are equal. It means that the triangle is an isosceles triangle. So it simply means that triangle CND is an isosceles triangle and triangle DNB is an isosceles triangle. So maybe I should just write it so that those of you that doesn't understand my accent will get a picture of what I'm saying. Okay, all I'm saying is that triangle CND is what? Isosceles triangle. Same thing with triangle DNB. And because triangle DNB is also isosceles, if I decide to call this base angle beta, then this base angle is also beta. Now you can see that here, this is what I now have in that particular place. I have this, then this is alpha, this is alpha. This is beta, this is beta. So you can see that this is alpha plus beta. All right, but you know that the sum of angle in a triangle is 180 degrees. Okay, I just want to be sure this is still on. Now the sum of angle in a triangle is 180 degrees, so it means that alpha plus beta supposed to give us 180 degrees. Now alpha plus alpha is 2 alpha. Beta plus beta is 2 beta. Is equal to 180 degrees. Now they share the same factor 2. So let's factorize out. 2 alpha divided by 2 is alpha. 2 beta divided by 2 is beta. Is equal to 180. So if we decide to divide both sides by 2, so divide by 2, divide by 2, this is 90, right? So it simply means that alpha plus beta is 90 degrees. So what is this telling us? That what we have here is angle 90 degrees altogether. That is all I wanted to prove there. So if this is angle 90 degrees, then this angle too is 90 degrees. Okay? Now let us join this A to this C with a straight line. Oh, my line is not straight. Okay. Now we have joined A to C. Okay. Now remember that the angle you are going to have here is 90 degrees. Why? Because this is a circle and this is the tangent of a circle. Okay. They are meeting at a point. So when a straight line touches the circle at the point of contact between a tangent and a circle, all right, you're going to form 90 degrees. So that is why that place is 90 degrees. Now let me explain further. If this is a circle, center 0, and this is a tangent, a straight line from the center dropping here, okay, makes 90 degrees with the tangent. So that's why this is 90 degrees. And if that is so, that means triangle ACB is a right angle triangle. Okay, remember that we are trying to find the area of this big circle. So triangle CB is a right angle triangle. Now, because it's a right angle triangle, we have this, we have this, we have this. So this C, this is A, and this is B. Now CB is 15, AB is 16 plus 9, which is 25, and AD is unknown. So using the Pythagorean theorem, according to Pythagorean theorem or Pythagoras theorem, it states that 25 squared, the hypotenuse squared, will be equal to AC squared, which we don't know, let's just call it X, plus CB squared, which is 15 squared. So if I transfer this 15 to the other side, I will have 25 squared minus 15 squared is equal to X squared. Okay, now if we use this theorem, remember this theorem that states that A squared minus B squared is equal to A minus B multiplied by A plus B. So in this case, our A is 25 and our B is 15. So we'll have 25 minus 15 multiplied by 25 plus 15, okay, is equal to X squared. So 25 minus 15 is 10. 25 plus 15 is 40, is equal to X squared. So if we solve further, moving forward, we will have 10 times 40 is 400, is equal to X squared. Now if we take square root of both sides, we will have square root of 400 is equal to square root of X squared. Now square root of 400 is 20, is actually plus or minus 20, but because we are talking about length, we are going to take the positive because length cannot be negative. So we have 20 is equal to X. Now why am I getting the value of our X? So here is 20. I want us to remember this theorem in circle, okay, about a circle. Now this circle theorem states that if you have a circle, all right, and this is the diameter of the circle, angle formed by the diameter on the circumference will always be 90 degrees, all right. So that simply proves that since this angle is 90 degrees, it's only a diameter that will make an angle of 90 degrees with the circumference, all right. So that simply means, or that proves, that AC is the diameter of this big circle. Therefore, AC is the diameter, all right. And we know that the radius of a circle is diameter divided by 2. So it simply means that the radius of this big circle will be equal to 20 divided by 2, which is equal to 10. And we are asked to find the area. Once we got the value of our radius, then the area will be found. Very easy. Therefore, area of the circle is pi r squared. So which is pi times 10 squared, which will give us 100 pi square units. And that is the answer. If you watched to this stage, I am grateful. Thank you for joining me, and I expect to see you next time.